Hey guys, this is the code chest and today we are going to discuss about data types in C along with the value range of each and every data type we are going to use and also the size or the memory they are going to consume from the RAM. So basically when you have to store values and use them in the future, you have to store those values in a particular memory location and you have to be able to know where that position or where that address is. So for that we are going to use variables. Variables are nothing but they are going to possess the address where your particular value is stored. So we cannot directly have a variable, we have to put what type of variable it is. It may be an integer or it may be a fractional number or any type of value it may be. It may also be a character, a symbol or some name or anything else. So for that we are going to use data types to differ what type of data is to be received from the user. So for the first point, to receive a value from user we need some address to store it. So when you are receiving value from the user or even if you are giving value, that value is to be stored somewhere so that you can use it afterwards. So for that we are going to use variables. Variable stores the address of the memory location in which our value is stored. So data types are given to describe what type of data is to be received and to create variables of that type. So if I'm going to give an integer, the variable of integer type is going to be created. In the same way, we are going to create any type of variable with a particular data type. So to create a variable, we need a data type space the variable name. So if I say I'm going to give an integer, I'm going to use a keyword int space a is my variable name. I'm going to give, we can give any type, any name according to the value we are going to receive. If I'm going to receive age of some person, I can write age as the variable name. After that you can end the statement with a semicolon. So in this case the A refers to the address of the particular memory cell. So here, as I told you, we are going to fix a certain memory for the value to be stored. What A does over here is it refers to a particular memory cell or memory location in the RAM so that the value can be stored over there and can be used in the future. So when I write int A, what happens is A refers to a memory cell and that may have any type of address. So A is not the address but A refers to the address. In this case 11101000 is the address. Alright, so when I give a value, that value is going to be stored in that memory cell and using A we can retrieve that value whenever we want in the program. So coming to the various data types which are present in C, we have void type, integral type, floating point type and derived type. Void type is nothing but, if you know the meaning of void is nothing but it is null. It returns nothing, it possesses nothing, no value. So why do we use void if we don't have any value to it? Normally we don't use it to take values, but we use it to in front of functions. When we define functions, if that function is not going to deal with, or if that function is not going to return any values, we are going to use void. So in case of variables, we are not going to use void. So coming to the integral types, we have boolean, which deals with 0 and 1, where 0 represents false and 1 represents true. Coming to character, characters are nothing but any alphabet from your keyboard, including numbers and also symbols. And then we have integers, which are nothing but the natural numbers negative and positive and 0. But fractional numbers are not allowed in integer type. And coming to the floating point, we have float and double. These two data types receive the values which are fractional in nature. I mean, if I say 23.23, 23.24, 12.15, so when we have point in the number, then we use float and double. So what's the difference between float and double? It's just the size and the range of values they possess. And coming to the derived types, they are user defined, so we are going to discuss it in some other video. For now, we are going to discuss about Boolean, character, integer, float, and double, which are below here. So now we have Boolean. As I have told you, Boolean holds only two values, 0 and 1. They represent false and true respectively. So 0 represents false and 1 represents true. And coming to the character, we have it holds any single character, including letters, the alphabet, numbers 0 to 9, and symbols, whatever symbol you may have on your keyboard. And values are to be written in between single quotation marks. Example, A. If I said A, it is to be written in between a single quotation. So the next one, the integer, holds values like numerical values, but not the values with decimals. That means not the values with fractional points in between. So if, for example, we have 34, and 34.5 does not work because there is a point in between the number. So when we have abscissa and manticide, don't work. And if we only have the integer without anything else, then it works. So coming to the point, float, we have holds value with decimal, so it's 32-bit data type. The difference between double and float is said over here. So in case of float, it is a 32-bit data type, and coming to double, it is a 64-bit data type. And the common thing in between float and double is they hold values with fractional numbers. So when we are going to implement these data types in the program, we have for Boolean, which is 0 and 1, we use underscore BOOL with B as uppercase. Normally in some compilers can have BOOL directly with every letter as lowercase, but in GCC, which we are using, we don't have anything any other thing, but we only have this keyword that says underscore B uppercase BOOL. And the memory taken by this Boolean data type is 1 byte. And coming to the character, we can use CHAR or lowercase letters. Remember that C language is case sensitive. That means if you write capital CHAR, it won't recognize it as a keyword. It does not recognize it as a character. So if it is small, if it is lowercase, you have to use lowercase, and if it is uppercase, you have to use uppercase. And the memory taken by character is 1 byte. And coming to integer, we can use it in various ways. Like if you're going to give a smaller value, you can use short int or short. If you just write short, by default it takes short int. So the memory taken by it is up to 2 bytes. And coming to the int, it takes 4 bytes. And long int or long, it takes 4 bytes, and long int and long 8 bytes. So the difference between all these things are nothing but size. So the value range that they possess is different. So short is for smaller values, int is for a little bigger values, long int is for even more bigger values, and long int is for the biggest values. So coming to the float, we have float, double, and long double with 4 bytes, 8 bytes, and 10 bytes respectively. And remember, this memory taken by these data types may differ from machine to machine and compiler to compiler. If I use a 64-bit compiler, a long double may use 16 byte of memory. It's all about the machine and the compiler which we are going to use. So that is why C is a machine dependent language. So the next we have signed and unsigned data types. So data types like int, long, and long can also be written as signed or unsigned data types. And remember, the floating point types cannot have signed and unsigned. So only this int, long, and long, and also char can be written as signed or unsigned. So what is the difference? What is a signed data type and what is an unsigned data type? Variables with signed data type can hold both negative and positive values. So there it is. When you have signed data type, that variable can hold negative values and also a positive value. Coming to the unsigned, it is just the opposite, which says values with unsigned data type can only hold positive values. So for implementation, we have just add sign or unsigned before the data type. So when you, in the previous example, you have seen int a. So if you are using an unsigned data type, you are just going to put an unsigned before the data type. So unsigned int a will create a variable a which only holds positive values. And in case of assigning an unsigned value, add u immediately after the number. So when you are having a signed number, you can directly add values without anything after or before it. But when you are going to use unsigned values, immediately after writing the value, you have to use a letter u, so that the compiler knows that it is an unsigned number. So I hope you have understand everything so far. So here we have demo.c. First of all, as you know, if you have seen my previous videos, we have hash include stdio.h and hash include conio.h, and conio.h is we use conio.h only when we run console applications. So if you're writing any other graphical interface, you don't need conio.h. So we had void data type. So we are not going to use that. I said we are not going to use that in case of variable. So in this case, the main method is not going to return any value. So I am going to use void for the main method now. So let me say void main. Now, as I said in the example, I'm going to write an integer int, and I'm going to give the name to the variable as a. Alright, and the value of a, I want to keep it like 46. So everything is good until now, but how about displaying this value to the user? For that, normally if we want to display something, we use normally printf, right? So how what do we write in between these brackets so that the value may be given to the user or displayed to the user? So if I write a directly, let us see what happens. So gcc space demo.c, there is an error. So we cannot directly give the value to the user, we need something else. Normally, if you have seen my previous video, you may have known that printf only takes string as an input. So string is nothing but everything in between double quotations. So what if I write it in between these quotations? It just gives a. I don't want that, I want the value of a. So for that we have format specifiers. So before we are going to continue with this program, we have to know about format specifiers of each and every data type, so that we may not be confused and we may not confuse the compiler too. So let's go to the format specifiers. So in this list you can see if you are going to display a character, we are going to use %c, and also for unsigned character we can use %c, and in case of short, unsigned, short, int and long, if you have known this thing, if you have remembered this thing, long and long int, both of them are similar. So we can use %d for that, and %e or capital E or uppercase E. For them we use float and double, and %f, g, f for float, g or uppercase G for float and double, and hi for short, hu for unsigned short, I for short and unsigned short, and int and long. So I have collected this list of all these format specifiers, and I'm going to give you all these things in our group, in our Facebook group. I cannot give this file directly in my page, so that to be able to share files with you people, I have created a group in Facebook, and if you like, you can join there and collect this file with all these format specifiers. So in case of this program, we have used integer, so int. So in int we have %d over here. So how are we going to implement that in the program? Let us directly go here and check that. So in place of a, we are going to use %d, but the compiler doesn't know what variable you are pointing at. For that we are going to use comma a. So what does the compiler do now is, first of all, it goes with %d, and then it will look for what variable we are pointing at. So when it goes here, it sees a. So after looking at a, it will go here, and afterwards it will go to a, and the value is 46, and finally it will print the value 46 to the user. So let us see how this will be displayed to the user. So we have gcc demo.c, and every time you make changes in the program, just remember to save it and compile it and then execute it again. So we have 46, which is our desired value. If you want something to be written before that value, as for example, let me say the value of a is, and then the value should come there. So we can directly write that like the value of a is. So everything will be printed as it is, and this %d will be replaced with the value of a. So we have the value of a is 46. Alright, now there is also we can also write these two statements in a single statement just by writing that 46 value over here. This time let me take other number, just like let me say 245. Why not? We can take anything, but there are some limits. So an int can take a certain range of numbers. It cannot cross that range of numbers, and I'm going to show you what are the ranges, what are the limits of each and every data type we are going to deal with in C language. So if I say 245, let me see how it goes. So the value of a is 245. So it's working very nice. So as I have told you, every data type has its own range, so it can only take values from certain value to certain value, and we are going to see what values are going to be taken by each and every data type in C language. So all the data types that we are discussing now are primary data types, or the predefined data types. So we have the secondary data types and derived data types, but we are not going to discuss them now. As we go to the next videos or the next tutorials, then we are going to deal with them. For now, let us look at these data types which are primary. Alright, so I have written this program to print all the minimum and maximum values, and along with the size or the memory they consume from the RAM while executing. So let me give all the list of those things. So when we come here, we have so when we include limits.h header file, then we will be able to import or use all these macros. So these are all nothing but the macros, predefined macros in this header file limits.h. To know the minimum value of a signed char, we use schar_min, and for maximum of signed char we use schar_max. In the same way, we use all these macros to find out the respective minimum or maximum value of any data type. So So for integer we have limit.h, and for the floating point, for float, double and long double, we have float.h. So to know all the values of every data type, we are going to include limits.h header file and also a float.h. So in the float.h we have the min value of float, maximum value of float, minimum value of double, max of double, min of long double and max of long double as well. So for them we have the macros float, flt underscore min, flt underscore max. So I have written a small program for that. I mean, it's not small, but it is a repetition of the same printf function, so it is basically small. Alright, so I have included limits.h and float.h for integral limits and float limits respectively. So first of all, we have to remember that the values may vary from machine to machine based on the compilers. So if you run this program in your computer, you may get other values than mine, so you don't have to worry, or you don't have to panic for that. Alright, so I have written limits of integral data types, and firstly minimum value for assigned char, I used %d, and the value is directly imported from schar min, which will give the value of the minimum signed char. Like that, I have written all the minimum and maximum values, and also we have a size of operator with which you can recognize the size or the memory they are going to use in your RAM while executing. So size of signed char or size of signed char is size of, and in the brackets you are going to write signed char, and for unsigned char you are going to write size of and unsigned char in the brackets. And in the case of unsigned int or any other data type, you are going to use size of, and you are going to write that data type in the brackets. Alright, now let me directly compile this thing and show you what it gives you. Alright, now we have CLS, which clears the screen for us, and gcc space sizes.c. I have saved that file as sizes.c. so here we go. This is the list of all the minimum and maximum values which every data type has possessed, and below here is the list of the memory taken by every data type. So you can make your own experiments in this thing. Alright, so in my case, minimum value for assigned character is -128 and maximum value for assigned character is 127. And in the same way, we also have every other data type and its minimum and maximum values. And the sizes or the memory taken by them are over here. And as if you have remembered that in our presentation, in our slide, we have size of long double as 10 bytes, but in my case it is 16 bytes. As I have told you, the values may vary from one machine to another machine and from one compiler to other compiler which you are going to use. So I am using a 64-bit compiler, so it takes 16 bits of memory in case of long double. In case of 32-bit compiler, it's going to take 10 bytes maybe. So it's all depends on the machine in which you are running this program. Alright guys, so I'm going to give you this program and the list and everything in our group. Open the code chest in Facebook. I will give you a link in the description so that you can join the group and access all these files. So if you're going to my page, you may not be able to download my files because Facebook pages don't have facility to upload files, or if I don't know how to. But I know how to upload files in a group, so I'm uploading all these programs, lists, and presentation, even the PowerPoint presentation. I'm going to upload them in the Open the Code Chest group in Facebook. So join the group to avail all these facilities. And until then, keep coding. If you have anything, please comment, share this video, and subscribe to my channel. That's it, guys. Code Chest signing off. Bye bye.